Although this issue is quite common, today I want to share a little knowledge with you. Let's take a look. This is a gray iPhone 12 Pro Max. The phone looks very new, with no major dents or scratches. Now, let's plug in the charger to check the issue described by the fan. After plugging in the charger, it shows 0 watts of charging power, and the screen doesn't respond at all. The phone won't turn on. Now, let's try pressing the volume up and down buttons, then hold the power button without letting go. We find that a forced restart has no effect. The issue remains. Reconnecting the charger still shows 0 watts. Looking closely at the frame, there are signs of paint peeling and oxidation. According to the fan, the phone stopped turning on after charging overnight, but we all charge our phones every night. So, what caused this iPhone 12 Pro Max to stop turning on? Was it the charging process or something else? Today, we'll use this phone to share a little bit of useful knowledge with you. I hope you double tap the screen to give me a like, and I also hope you watch until the end. Thank you for your support. We start by heating the phone and sliding around the screen edges to open it up. After inspecting it, we confirm that the phone has never been repaired before, just as the fan described. First, we protect the front camera components. Then, we remove the screws securing the metal shields. Now, let's disconnect the power. Next, we detach the display, followed by the earpiece flex cable, and finally, we can remove the screen. The screen looks flawless, no issues here. Now, since the phone won't turn on, we need to check the motherboard. We start by removing the motherboard, disconnect all external flex cables, unscrew the mounting screws, remove both the SIM tray and internal components. Finally, we take out the motherboard. The iPhone 12 Pro Max still uses a dual-layer motherboard design. We inspect it and find no signs of physical damage. Since the motherboard won't power on, we test it with a power meter. The meter shows a short circuit. This indicates that a short circuit on the motherboard is preventing it from turning on. We place the motherboard under a thermal imaging camera. At this moment, we cannot see any short circuits on the outer layer. This suggests the issue might be inside the motherboard, so we remove the foam pads and adhesive. Then, we place the motherboard on a heating station. Once the solder melts, we separate the two layers. Some people quietly watch videos, but they secretly like, comment, share, and follow. Such people are truly lovely. The motherboard appears to be opened for the first time. Let's inspect the lower layer first. Many people ask why there's an empty chip slot. In Chinese models, this space is empty, but in US versions, a chip is installed here. This section includes the Wi-Fi and baseband chips. Meanwhile, the upper layer contains the CPU, power supply, charging circuits, and storage. We need to determine whether the short circuit is in the upper or lower layer. First, we test the upper layer with the power meter. If you like this video, please send me some gifts to support us. The upper layer still shows a short circuit. This confirms that the problem is in the upper layer. We check with the thermal imaging camera again. No clear heat spot is visible, but we see slight heating near the CPU. Oh no, does this mean the short circuit is on the outer side? Checking the schematics, we find that the CPU side has no components. However, the reverse side contains capacitors and resistors. These two capacitors are related to the main power supply. To confirm the issue, we secure the motherboard in a clamp. Next, we apply flux around the shielding cover and heat it to remove the shield. If you like this video, please send us some gifts to support us. After removing the shield, we inspect it under a microscope. To improve visibility, we apply white rosin smoke and test again. Sure enough, the heat spot is on the outer side, but we couldn't see it earlier due to the shield. Now that the motherboard is separated, we can pinpoint the problem. We remove the damaged capacitor, clean the solder pads, and prepare a new high-voltage capacitor of the same specifications. Then, we carefully solder it into place. After cleaning everything, we test the power again. The short circuit is gone. Now, we press the power button and the phone boots up. The power current is normal, confirming that the faulty capacitor was the cause of the issue. Problem solved. We reassemble the motherboard, reattach the shielding, and clean the solder points. Now, let's discuss an important question. Why do Apple capacitors short-circuit more often than Androids? Many people assume that Apple's capacitors are lower quality, but this isn't entirely accurate. In reality, Apple and Android manufacturers use similar component quality. However, Apple's circuit design and ultra-thin motherboard structure may make capacitors more prone to failure under stress. But why do capacitors fail? Capacitors store electrical energy. Typically, one side is grounded, while the other is part of the power circuit. When a phone is dropped, the motherboard flexes, and capacitors can crack internally, causing short circuits. Heat fluctuations, electrical surges, water damage, and natural aging can also lead to capacitor failure. This fan's phone stopped working after charging overnight. This suggests that improper charging may have contributed to the failure. To avoid such issues, always use original or high-quality chargers with overvoltage and overcurrent protection. Avoid overheating your phone and minimize heavy impacts. Now, the iPhone 12 Pro Max is fully functional again. This is a 512 gigabytes Chinese version, and all functions are working normally. Thanks to every fan for your support. Double tap if you like this video, and don't forget to follow for more exciting content.